So I'm Hamzah, I'm the Vice President of Engineering at JetX Engineering, and we're here at RIAT 2019. JetX Engineering is a student body founded in 2014 at the University of Glasgow with the intention of providing high-level aerospace education to undergraduate students. The aim is to provide students with the ability to follow a long-term, complex project from its concept phase right the way through to its final testing and manufacturing. What we do is we design from scratch, 3D print and test jet engines. The key difference with us, because jet fuel and plastic doesn't mix so well, it look fantastic for about a second in testing, we use a pneumatic system to simulate combustion, but all the other components in the engine work exactly the same. Everything is driven from the turbine, the fan and the compressor. The way we design it is we design it from our theoretical model. We sit down, we go through our mathematical models, and we then come up with the initial CAD. From there, we go into the simulation and optimization phase using CFD and FEA, and then we move into 3D printing, and then final testing. And 3D printing was selected as the medium of manufacturing because it's really easy and really accessible, and relatively cheap. Up to this point, we've manufactured one high bypass turbofan engine for display. This is the Explorer 1. This took about 2 years from its concept through to its final manufacture. And then recently we made an engine, an upgraded, almost generation 1.5 version of XP1 to sell to the University of Sheffield. The Explorer 1 was the first 3D printed jet engine in the world to have an integrated electronic engine monitoring system. So that's a full sensor and software suite built into the engine that allows us to see vibration, pressure, temperature and rotational speeds of the shafts throughout the length of the engine. And that piqued the interest of the University of Sheffield, so they bought an upgraded engine from us to then test their own algorithms that will be fed into high-level Rolls-Royce manufacturing research. Up to this point, from there, we've moved into 2 new programs, a Generation 2 version of called Explorer 2, which again is focusing on high bypass turbofans, and then Kronos, which is our military-based program. That folds in a lot of technology that you see on the EJ200 or the F-22 Raptor engine, such as thrust vectoring, twin fan, and contour rotation. And the reason we do it, the reason we've made it so complex, is so that we can give the undergrads and give the students the ability to work on a really complicated project far beyond the realms of what they'd experience within their curriculum. Within the curriculum, you don't really get a long-term design project. It may be purely theoretical or it may only last a semester, but what we do spans multiple years. Kronos and Explorer 2 will be approximately 3 to 3.5 years from start to finish. So it's a very long-term project that allows someone to move through and develop all these different skills and enhance their curriculum and ultimately develop the skills that are required